Hi everyone. Wow. I have to say this perspective looks so much great than a web event, and I have also to say prior we start how happy I am to be back here after. It feels like it has been so long time, like too long. So hopefully for this year and other 10 years in presence. So let's start. What we'll speak about today? We'll speak about monitoring MySQL with Zabbix, understanding the metrics. What does it mean? We'll discover in a while. First, for all of you who do not know me, a few facts about myself. I am Vittorio, and I have been a Linux MySQL user since I can remember, honestly speaking. Last years I have enjoyed working for MySQL and regularly appearing at conferences. This is honestly one of the best parts of my job currently. So you might remember me from the last couple of Zabbix summits. Originally I'm from Italy, but I live in Warsaw, and I like movies, cooking, traveling. I actually love traveling. All right, it's enough about myself. Let's see what we'll speak about. So, what does it mean understanding the metrics? Yeah, we can monitor MySQL with Zabbix, which is amazing, and it does really a great job. But do we know actually the meaning of what we are monitoring? That's what we'll discover. So we'll have a brief recap of MySQL and how it works. Then we will try to understand the key metrics, like the key metrics that Zabbix collects from MySQL. Not all of them, otherwise we would stay here discussing until the next Zabbix summit. But the key metrics in the area of connection handling, memory buffers, log files, so disk structures, and query execution. All right, so MySQL and how it works. What is MySQL? Everyone knows, I think, in this room. It is the #1 open source database, and pretty much any stat you can find around the internet will confirm it. In 2019 got awarded as DBMS of the year, and it can be monitored. It should be monitored because, as one of the previous sponsors which appeared on this stage says, and they have a very beautiful slogan on their booth, monitoring the database, it's the base. So it should be monitored, and we can monitor it with Zabbix. Starting monitoring MySQL with Zabbix is actually really easy, because to get started, it's enough to install the agent 2. Then you create a user with monitoring privileges. Then you create the host with the Zabbix agent interface. You assign the MySQL template to the host, and you are pretty much done. You adjust the user macro values to match DSN, username and password, as you can see from the screenshot. So, okay, this is easy. And this will give us an overview, like the MySQL template will give us an overview and much more. So we can see, for example, if the server is up, if the uptime and other general metrics, if you are having a problem. And here it gets difficult because MySQL provides a lot to Zabbix, a lot of metrics, like really a ton of them. So do we need to know all of those metrics? What's important to know, and once we understand what's important to know, what does it mean? So to understand this, we need to take a step back and have a look at the overall structure of the MySQL server. So the structure of MySQL Server, it's what we like to call the pluggable structure. Everything, regardless of what it is, it's treated as a plugin. Even the storage engines are a plugin, as we'll see in a moment. So what we have in the structure, we have connectors, then we have the connection pool inside, and then we get inside the server where we find the connection pool, and then we start to get plugins like the SQL interface, it's a plugin, the parser, it's a plugin, the optimizer is a plugin, the storage engines are plugins. So like we have a ton of existing storage engines for MySQL. For convenience, everything we will speak about in this presentation will be referring to InnoDB. For example, if someone is interested in knowing what NDB is, well, we can discuss in front of a beer. But today, for the sake of this presentation, everything refers to InnoDB, which is the most popular storage engine. Then we have file structures, because at the end of the day, MySQL stores everything into text files. Okay, so we understood the overall structure of the MySQL server, and this represents what runs in the MySQL process on your Linux, hopefully Linux machine. Then let's try to understand the storage engine architecture, how InnoDB works. There are a set of memory buffers, one of the most important, like the king of the buffers is the InnoDB buffer pool. There are also other buffers like the change buffer, the log buffer, and then there are the disk structures. Like there are a set of these buffer and structures like the data dictionary, double write buffer, and then you have the undo and redo logs. And then you have the table space, so the actual files. Hopefully in your MySQL which you are using, you have the file per table option on. Otherwise the performance of the server will kind of struggle very much, but if you are using a version which does not come from the dinosaur era, that's enabled by default. All right, so now we have understood how MySQL works. Let's start seeing the key metrics, which then at the end we will see what Zabbix shows us. So in terms of connection handling, can we speak about connection handling without understanding how it works? Of course not. So this is the way MySQL handles connection. There is a phase of connection establishing where the client will provide credentials and it will get a thread assigned from a buffer or created appositely. Once the connection is established, there will be the user thread and the client will hook up to this user thread, will do its stuff, and then we will send a close signal. The user thread will come back to the thread cache, and the connection will be ended. So what are the important metrics related to the connection? This is valid for every version of MySQL, especially for community. Max connection. So this is the key metric I have to keep in mind, because if I set it too low, the application might not be able to work properly. If I set it too high, I might knock the server down. Why? Because the connection, each connection requires memory, and not only. Each connection opens up actually a file on the operating system. That's why you might need to increase the U limits more than the standard depending on the workload. So yeah, remember to set U limits and file descriptors. So what can we monitor with Zabbix? We can monitor the threads connected, which based on the corresponding variable of the show status, we can monitor the threads running which are not sleeping, which is quite an important metric because I can see the threads which are actually doing stuff, and the threads cached. Also, I can see the connection per second, and those, like here, we see how the corresponding graphics are looking like. This is, for example, the graphic of connection per second, which actually I kept very low on purpose, and then I generated the spike. And I can get here out of the box a beautiful graphic of the MySQL threads. Like I can see the threads cached in green, I can see the threads connected, and I can see the threads running. So I can see that I have quite some threads connected, but running not very much. So the majority is sleeping. So I can get out of the box really everything I need to check the connections. And now I hope we understand a bit better how this works. Let's move on. So before we move on, I wanted to say also another thing in general about this presentation. This is a presentation I wanted to make for quite a long time, but I was waiting to be back. Now, the memory buffers. The king of the buffers is the InnoDB buffer pool. Okay, I put one slide back. Who knows how the InnoDB buffer pool really works? Really? All right, so we will understand how the InnoDB buffer pool really works. So normally the InnoDB buffer pool is this obscure object which takes up to the 80% of the memory of the machine. Okay, why so? Now we'll see why so. First of all, it's not up to the 80% of the memory, it's between 50 and 80% of the free memory, which is a completely different thing. So, the InnoDB buffer pool is, as you can see on the slide, a place in the memory where InnoDB holds the data which is accessed, but it holds them in a specific way. It holds the hottest, let's say, data, the data which are more frequently accessed. So the data under the hood are categorized, are stored in chunks called pages. So the InnoDB buffer pool stores the frequently accessed pages in a way similar to a bubble sort. So the hottest goes up and the coolest goes down, like it happens with actually with the air. So the hottest goes up, the coolest goes down. They don't cross at midway, and there is no rain in case of the buffer pool, but it's actually the way it works. So it works in a non-deterministic way, because I can know, for example, which tables I expect to access the most, and I mentioned the buffer pool in correlation of the size of these tables, but which exact chunks of data will be accessed, in the most of the cases, I can't predetermine. All right, so how does it configure? There is the king variable for MySQL optimization. Whenever I start a MySQL optimization, we start from this variable, the InnoDB buffer pool size, which as of MySQL 5.7 can be accessed dynamically. All right. On dedicated servers, from 50 to 80% of the physical memory, and I can set the number of buffer pool instances. As a rule of thumb, every 2 gigs of buffer pool counts as one instance. I can save the buffer pool status in order not to have to warm up the buffer every time I restart the server, so having pretty much the same performance where I've left off, and I can save the determined percentage of the buffer pool as well. Also, I can show the status of the loading like with this command. If I want to see the size of the buffer pool and I'm not yet using Zabbix, I can use this very big query, and if anyone without memorizing without taking a picture is able to memorize these and to repeat it to me, it will get from 5 to 10 dolphins at the boot. So, and as you can see, the result of this query, it's pretty much the same as what I got using Zabbix. So this is the actual query you can use if you need to. About the memory usage, the buffer pool takes a lot of the memory. Another thing which I want to configure is the table open cache. So the table open cache, it's a variable which defines the maximum number of tables which I can keep open concurrently. It gets held in memory, but it also influences the maximum number of open files on the server. So again, check the ulimits. How we can monitor these beauties with Zabbix? So we have the metric which speaks about the buffer pool utilization, and also this is the way how Zabbix calculate that percentage. And if you, it's fairly similar to that query. I would say it's a more accurate calculation because it refers to the last runtime values. As well, I can calculate the buffer pool efficiency. So how much of the buffer pool am I using, a level of efficiency for the buffer pool, which is a great information, which of course MySQL out of the box does not give, but using the read requests, and combine it into a percentage, Zabbix is able to calculate how efficiently am I using the buffer pool, and this is not a small thing. Also, I can get a graphic with a breakdown of the buffer pool utilization. So I can get the pages free, the total of the pages, the read requests, and the actual hits to the buffer pool, where the read requests per second, I can get the read requests per second, so I can see how many reads are actually being served from memory, but also I can see with buffer pool reads, so the name of the variable is misleading, but it shows how many pages are being served from disk. So if the pages from disk are too much, what do I need to do? Sorry?
Increase buffer size.
Exactly. Exactly. And I can get the total stats of the open tables. So to dimension the table open cache, I need to look at this value here, opened tables. Now, so we have set up the memory. As you see, to start, a good MySQL optimization does not require to tune 100 or not 10 parameters. It requires that 4 or 5 parameters. Then whenever you hit that performance bottleneck, once you have optimized, you refine further. But to start off very efficiently doesn't take much. Then let's see now what MySQL keeps on disk, the log files. I'll say immediately, among all the disk structures, I'll focus on redo logs and binary logs. So, what are the redo logs? The redo logs are data structures, so basically files where MySQL keeps track of the changes which are being written to the database. So they are controlled, there are normally two files, they are by default, and they are controlled by two parameters. InnoDB log file size, which defines the size of a single file, and InnoDB log files in group, which defines the number of files. So the total size is easy to calculate, and the data prior to getting written to the log are being written to a memory buffer, which is called InnoDB log buffer size, which isn't very big unless you are writing very beefy amount of data in a single chunk. But it can be increased a little bit. Normally the magnitude is in the order of the 32 or the 64 megabytes. So, again, if you have a write-intensive application, consider using a dedicated disk for hosting the binary log, and another disk, for hosting the redo logs, and perhaps another disk for the binary logs. So, how do I increase the performance here? Because that depends. I mean, once I have increased the buffer, the speed of writing depends a lot on the system. There is a trick I can do, but it's a risky trick. Like if you want to get more traction on your car, you disable the assisted traction. Here you can play with this variable InnoDB flash log at transaction commit. So this variable regulates how often the binary logs not the binary logs, sorry, I keep mistaking. The redo logs are being flashed to disk. Default is 1, so every time there is a commit, for every transaction by default or at every commit, the binary logs, the redo logs, sorry, are ending up to disk, so to the database files. Sometimes if I write too intensively, there's not enough. So I have to take the risk, or if I can take it, of course, I need to face the risk of losing some data if I want to push it even further. The safest is value 2. So the redo logs are written at every transaction, so the data are written from memory to the log at every transaction, and they are committed every second. So if I have a crash, I have still the redo logs, so I might not lose data. Or if I feel I want to go extreme, I can set it to 0. So the redo logs will be written and flashed to disk every second. The default is 1, and the log flashing frequency is controlled by this variable. So this is the parameter that I can tune when I have a write-intensive application with the hardware I have can't write more. Now, something more friendly, the binary logs. So the binary logs are containing binary chunks, so data in binary format, describing the changes which are happening in the rows. So whenever something is written, that change is taken in binary format and is written into the binary log. They slightly decrease performance, but they're very useful. They're useful, for example, for point-in-time recovery and for other things which we'll see. So, the binary log format is regulated by the variable binlog format, which can be statements. So I get the SQL statements in the binary log, row, which is the default from MySQL 8, and mixed. So row describes the changes, the rows which are physically changed. And this is safer than statement because sometimes different executions on different servers could end up in a different way. All right, so also I can read the binary log. They are available in a human readable form, or I would say almost human readable form, with the tool MySQL binlog. And also for the binary logs, consider using a dedicated volume. Why? Because the data written on disk, the redo logs, the binary logs all on the same disk, if I write quite intensively, will just affect negatively the performance because I have 3 processes competing for disk. Now, the binary logs are being used for replication process. They are being used for the classic asynchronous replication, where the changes are written into the binary log, they are transferred to the redo log and applied on the replica. And they are being used for group replication, so to say, InnoDB cluster. I have spoken about InnoDB cluster here some years ago. Basically, it is almost synchronous or a semi-synchronous replication technology, which is anyway based on the binary logs. So, what can we measure with Zabbix? The calculated value of the InnoDB log file size for the redo log, and as well the binary log size. The binary log size, I calculated it using a custom item, and here you can find the definition. By the way, thanks a lot to the Zabbix team, which helped me with the syntax of the custom items. And as well, I also, with the help of the Zabbix team, managed to set up a custom trigger where I calculate one very important thing, when the binary log is filling up disk space. So I set very conservatively the threshold to the 50% of the disk space I have available. So when the binary log overcomes that percentage, but it's easy to modify, you have the entire syntax here. So when you overcome a certain threshold, you get an alert, because one of the major causes of replication breaking, it is the disk space is filled up, and very often is filled up not by the data, which we kind of remember to keep under control, but by the binary logs. So here we go. Now, let's change a little bit topic now that we are approaching the end of this presentation, and let's speak about query execution. So, to understand query execution, we should understand a little bit how the MySQL optimizer work. So, the optimizer is the object that gets a query and calculates a cost model. So, chooses the best among different possibilities of running a query. That's why different queries after optimization can end up being the same query. Now, how can I check what the optimizer is doing? I have basically 2 ways. I can use the command explain put in front of the queries, and I will get an explain plan. So table by table, the optimizer will tell me if he's using a join, if he's using an aggregation, which indexes are being used. And I can run the explain for select, delete, insert, replace, and update. How does an explain plan looks like? Now, on the right, we have a bad explain plan, where we see that I'm scanning a very high number of rows without using indexes. So then I do some magic, I add an index, and we understand. So this is the query. It's a rather simple query, but without an index on actually the salaries. I am scanning 2 million over almost 3 million rows. Now, with an index, the rows which are being scanned go down to 7. So from 3 millions almost to 7. And this is the kind of information that the optimizer can give us about the bad queries. Also, I have another tool. I have the explain analyze command, which tells me basically how much a query will run in terms of time. So I am adding further information on top of what the optimizer gives me. Anyway, when we are speaking about queries performance, because before showing what Zabbix can monitor, we have to do some further consideration. First, very often if I'm using a third-party application, I don't have control over the queries which an application is running, but when I have control, I should ask myself those questions. So, am I using the right data types and clauses? Does each table have the appropriate column? Am I using the minimum length possible which I should use? Does the table have a primary key? Because very often that comes down being important. And is the table indexed properly? This thing about indexes I can use also with some third-party application. Not all, but sometimes the DBA can do some magic. Now, what can we monitor with Zabbix? So we can monitor the commands per second broken down by command. So delete, select, insert, and update. And this is actually very, very useful. I can monitor the InnoDB row lock weights. So here I can see when I was executing a test, I had more locks and then it went down. I can monitor the queries per second with the using an item with the related time series. So the beauty of this is that every item you get gets converted as the associated time series graph. So I can keep track of how much queries are being executed and how much locks I am getting on the database, because the logs is an indicator which can tell us how much we risk that the performance suddenly goes down, because more rows are getting locked, less rows can be utilized. Even though InnoDB does a lot in comparison of older engines in terms of locking only locally, but still, when I get read-write very intensive applications, this can be a problem. So, we are approaching to conclusion. What have we done? We spent 34 minutes analyzing the most important queries. We have seen what are the most important parameters which Zabbix monitors. Not that the others are not important, but if I want to start to monitor MySQL and I'm approaching to it like a black box, I can start from this safe set of parameters. And you will see when it gets represented on the dashboard, it's not such a small set. It becomes quite a complete dashboard in the end. So we have reviewed the internals of MySQL very briefly, maybe too briefly, but enough for the purposes of what I had to explain. We have understood which metrics are behind the parameters, and we have digged a little bit as well in the components of these metrics, so where the metrics come from. So hopefully we have understood as well how to control those components and optimize the metrics. So, and here I leave you a some small tips about performance optimization. My favorite is don't take best practices as absolute truth. So always do one thing and test. And with the help of Zabbix, you'll get quite a complete overview. So that's all from my side. I was very happy to be here. I hope now we have a little bit better understanding of what the monitoring panel is showing us. Thank you, guys.